Hello everyone, welcome to my YouTube channel. In today's session, I'm going to tell you about the very important 120 MCQs regarding 0620 chemistry. So this session is especially for those students who are going to appear for their final CAIE examination, especially IGCSE chemistry. Let's start from the question number one. But before starting the question number one, uh, let me tell you that I'm also going to tell you a lot of extra points as well regarding the specific topic in the question. So let's start from the question number one. Which statement about graphite explains why it is used as a electrode? If something is used as a electrode, it must be a good conductor of electricity. So the conductivity is the reason. So for the conductivity, the substance must contain either the delocalized or the mobile electrons, either the delocalized or the mobile electrons or free ions. So graphite is a solid, so it contains mobile electrons or it contains delocalized electrons. If we replace the graphite with a giant ionic structure, for example, if we say that the sodium chloride is a good conductor of electricity, so in the sodium chloride, the used so mobile electrons or delocalized electrons are responsible for the conductivity of graphite. Uh, now, free ions, they are responsible for the conductivity in ionic compounds, giant ionic structures or ionic compounds. So, ionic compounds in solid and in liquid or molten, they are good conductor. Sorry, in aqueous and molten, they are good conductor. In solid, they are poor conductor. So mobile electrons are responsible for the conductivity of graphite as well as for the metals. So in metals and graphite, mobile electrons or the delocalized electrons are responsible for the conductivity. So that's why they can be used as an electrode. But in ionic compounds, the free ions or the movable ions, they are responsible for the conductivity, but they cannot be used as electrodes. Okay, now the next is methane burns in the air to form carbon dioxide and water. What is the balanced chemical equation for this reaction? Whenever you get the carbon dioxide and water, so the carbon dioxide is produced when the substance reacts with the excess air, because in limited supply of air, carbon monoxide will be produced. So this is the balanced chemical equation. Methane is gaseous substance at room temperature. Oxygen, this is carbon dioxide, this is water. Just look at the balancing. There is one carbon, four hydrogen atoms, two times two, four, and two plus two, four oxygen. So this is four oxygen. So if we replace the methane with the different hydrocarbons like ethane, C2H6, if it burns in the presence of excess oxygen to get carbon dioxide and water, let's balance this chemical equation. First of all, balance the carbon. There are two carbons, so you just put two here. Six hydrogens, so put three here. Now look at the number of oxygen atoms. Four plus three, seven oxygen atoms. So seven by two or three and a half. So 3.5 times two, seven. If we replace this C2H6 with C3H8, which is the propane. It combines with the oxygen to form carbon dioxide and water. And just balance this equation. First of all, carbon, then hydrogen, then oxygen. So there are three carbons, so put three here. Eight hydrogens, so put four here. Now three times two, six plus four, 10. Now five times two, 10. So if we burn the 1 mole of alkanes like methane, ethane, propane. So just look at the number of oxygen atom. There were four oxygen atom, two moles of oxygen atom, then 3.5, and then 5. So 1.5 mole of oxygen atoms, oxygen molecules, sorry. 1.5 moles of oxygen molecules are added, then add 1 mole of carbon dioxide and 1 mole of water. Now, which gases are used to generate electricity in a fuel cell? So, a fuel cell, what is fuel? Fuel is a substance which releases energy when burned. And mostly in the fuel cell, the hydrogen is used as a fuel. So hydrogen reacts with the oxygen from the air. Oxygen comes from the air. Hydrogen is a fuel. It reacts to form water. And this is the balanced chemical equation. So hydrogen loses the electron and oxygen gains electron. So that is an electrochemical cell. It produces electricity. This is electrochemical cell. So it produces electricity, and oxygen and hydrogen, they react with 2:1. So for every 2 moles of hydrogen, there must be 1 mole of oxygen. So we can say that this reaction is between hydrogen and oxygen. So hydrogen is the fuel, oxygen comes from the air. So hydrogen reacts with oxygen to make water. So water is the only product which is formed. This is the only product which is formed in a fuel cell. So we can say that the advantage of the fuel cell is that only one product, water, is formed. So no air pollution. You can say less noise produced by the engine, more energy per kg. And there are some disadvantages of the fuel cell as well, that it is comparatively expensive and it is less efficient at low temperature. And then it is difficult to store hydrogen gas, or it is expensive and difficult to store hydrogen gas. Now, the next point is which statement about hydrated cobalt 2 chloride is correct. So this is the hydrated cobalt 2 chloride. So the color of the hydrated cobalt 2 chloride is pink, and anhydrous 2 cobalt 2 chloride is blue. So the equation from left to right, this is used to test for the presence of water. That water turns anhydrous cobalt 2 chloride from blue to pink. And when you have the hydrated cobalt 2 chloride, it turns from pink to blue upon heating. So from left to right, we can add water plus water, and from right to left we can heat it. So this is hydrated cobalt 2 chloride, this is anhydrous cobalt 2 chloride. Just think about the some properties or the points. It turns blue when it is heated. Yes, it turns blue when it is heated because it will be converted from hydrated to anhydrous. So hydrated is pink, anhydrous is blue. Hydrated cobalt 2 chloride is pink. Yes, hydrated cobalt 2 chloride is pink. Water turns anhydrous cobalt 2 chloride from blue to pink. So this is blue to pink. Anhydrous cobalt 2 chloride is from blue to pink. Now, when we heat this reaction from right to left, that is endothermic, because hydrated, there is a bond breaking, you can say, between this water of crystallization and cobalt 2 chloride. So from left to right, the change is endothermic. From left to right, from right to left, is change is endothermic, and from left to right, the change is exothermic. From left to right, the exothermic, and from right to left, endothermic. Now, there is another substance which can also be used to test the presence of water, that is anhydrous copper 2 chloride. So these are the two reagents used to test the presence of water, anhydrous cobalt 2 chloride and anhydrous copper 2 sulfate. So just look at this. This is hydrated copper 2 sulfate, or copper 2 sulfate pentahydrate. So the color of hydrated copper 2 sulfate is blue. These are the water of crystallization, and anhydrous to copper 2 sulfate is white. So it turns white when it is heated. Yes, it is when it is heated. the water of crystallization, they are removed, so it turns white or from blue to white. Hydrated copper 2 sulfate is blue. Yes, hydrated copper 2 sulfate is blue. Anhydrous is white. Water turns anhydrous copper 2 sulfate from white to blue. Yes, water turns anhydrous copper 2 sulfate from white to blue. So to test the presence of water, anhydrous cobalt 2 chloride and anhydrous copper 2 sulfate are used. So anhydrous cobalt 2 chloride turns from blue to pink, and anhydrous copper 2 sulfate from white to blue. Then the next point is uh, an aqueous solution reacts with the solid. The products are alkaline gas, salt, and water. What are the aqueous solutions in the solid? Whenever you get the alkaline gas is ammonia. And if we're getting the three products, salt, water, and ammonia, this is the property of a base. Whenever we have a ammonium salt, like ammonium chloride, ammonium nitrate, ammonium sulfate, and if it reacts with the uh, alkali or a base, we'll get salt, water, and ammonia. So the solid which reacts with the base to form aqueous solution of a base to form alkaline gas, salt, and water. So the aqueous solution is sodium hydroxide, and the solid is any ammonium salt, either ammonium chloride, ammonium sulfate, ammonium nitrate, and this is the alkaline gas, ammonia, which turns moist red litmus paper blue. Now, this is the property of a base. This is the property of a base. Now, the seventh point is an aqueous solution reacts with solid. So you have to identify the solid and the aqueous solution in which the products are acidic gas, salt, and water. So this is the property of acid, that the solid must be the carbonate. It must be the metal carbonate, and metal carbonate reacts with the aqueous solution of acid to form salt, water, and carbon dioxide. So the acidic gas is carbon dioxide. So if we have a metal carbonate, if it reacts with the acid, we will get three products: calcium chloride, salt, then water, then carbon dioxide. So whenever we get the alkaline gas, that can be obtained by reacting the ammonium salts with the sodium hydroxide or aqueous solution of, we can say, the base, or uh, if we are getting the carbon dioxide, metal carbonate react with the hydrochloric acid to get carbon dioxide. So ammonia turns moist red litmus paper blue, and carbon dioxide can be tested through lime water. It turns uh, the lime water milky or the cloudy. Then the eighth point is that the copper 2 sulfate is prepared by adding excess copper 2 carbonate. So excess copper 2 carbonate to the sulfuric acid. This is the copper 2 carbonate. If it reacts with the sulfuric acid, the products are copper sulfate and then water and then carbon dioxide. So metal carbonate react with the acid to form three products, like the question number 7, salt, water, and carbon dioxide. So why is the excess copper 2 carbonate is added? Now uh, this is aqueous and this is aqueous. So if we use the excess copper 2 carbonate, actually, if this is in excess, so sulfuric acid must be the limiting reagent. So the limiting reagent consumes earlier as compared to the reagent which is in excess, because excess mean more than enough. So copper carbonate access, why it is used in access to utilize to ensure that all the sulfuric acid has reacted. Because if you're getting the salt, salt is also aqueous and sulfuric acid is also aqueous. So if the sulfuric acid is in excess, although it uses all amount of the copper 2 carbonate, uh, if this is in excess, so it will use all amount of the copper 2 carbonate, but the sulfuric acid is in aqueous solution, salt is also in aqueous solution. So you may get some contamination of sulfuric acid in copper 2 sulfate. So to utilize all the amount of sulfuric acid, copper 2 carbonate is used in excess amount of the copper 2 carbonate, because this is solid, so that can be removed through filtration. So if we filter, we can get the extra amount or the excess amount of copper 2 carbonate, because the rest of the reagents, they are in like or aqueous or in liquid or gas. Number 9, some information about element X is given. Melting point 64. Comparatively, it is low melting point. Density, it is low density. Vigorous reaction with the water. So the vigorous reaction with the water mean they must be alkali metals. So alkali metals are in group 1. So this is the property of alkali metals, that they have low melting and boiling points, they have low density, and they will show the vigorous reaction with the water, like sodium, potassium, rubidium, cesium. They react vigorously with the water to make, if we react the sodium with the water, uh, sodium hydroxide, metal hydroxide plus hydrogen, and this is the balanced chemical equation. So hydrogen gas will be produced, which pop up in a lighted splint. So the answer is group 1. So these are actually the questions in which you can directly predict the answer, because whenever you have a question like melting point low, density low, vigorous reaction with the water, the group 1 is the answer. Although you may have some other options like group 7, group 8, transition elements. So transition elements, they have the high melting point, they have the high density. So no, especially no reaction with the cold water. They can react with the steam. Noble gases, group 8, they do not react with the water. Then the group 7, they have some different properties. So that's why these are the questions in which you can directly predict the answer just by just checking the informations which are in the question. Now, part of the periodic table is shown which element has 2 electron in its outer shell and 3 electron shell. So the electron shell, they are concerned with the period, mean the period number is equal to the electron shell, and outer shell concerned with the group number, because group number is equal to the number of electrons in the outer shell. So if 2 electrons are there, it must be in group 2 of the periodic table, and if 3 electron shells are there, it must be in third period of the periodic table. Whenever you want to check the period number, just start from here. This is 1, this is 2, this is 3. So third period. So there are 2 elements in the third period, C and D. So it means that you can eliminate A and B. Now, group 2, there is just one element in the group 2. This is group 2. This is 3, 4, 5, 6. This is group 6. So you can eliminate the D. So it means that C is the appropriate answer. C is in group 2 and period 3. Which description of the brass is correct? This is the direct question. The student must know that the brass is a mixture of zinc and copper. So these are the 2 elements which are present in the brass, and brass is not a compound. Brass is a mixture of these 2 elements, zinc and copper. So a mixture, or the you can say that this is alloy, and alloy, the different metals are of different size. So that's why they must have some different properties of the metal. This is also a direct type of question in which no extra informations will be required. So stainless steel as a mixture of dash. So the student must know that iron is the major element which is present in the stainless steel, and then chromium, nickel, and carbon. So carbon is a non-metal which is present in almost every type of steel to some extent, mean low carbon steel, high carbon steel, or medium carbon steel. But in stainless steel, the other elements are chromium and nickel, along with the iron. Which property of the steel makes it suitable for making cutlery? So stainless steel in cutlery, because of its hardness and resistant to rusting or corrosion. So this is a specific answer that whenever the stainless steel is used as a cutlery, so the first thing is that it is hard because stainless steel is a alloy. So alloys are comparatively hard as compared to their metals, and it is resistant to corrosion. Then, what is the symbol for the metal used in the manufacture of aircraft because of its low density? So, in aircraft, the aircraft body is made up of aluminium. So, this is the direct answer that whenever there is a question regarding the aircraft body, so that is the alloy of aluminium. So, aluminium is the major element which is present in larger proportion. Now, you can answer these type of question if you look at your syllabus or specification 9.2 uses of metal. So just read the 9.2 uses of metal, then you will be able to give answers regarding these type of questions. Uh, and these questions are very important. Let me tell you about the 4 points. Aluminium in the manufacture of aircraft because of its low density. Aluminium in the manufacture of overhead electrical cables because of its low density and good electrical conductivity. Aluminium in food containers because of its resistance to corrosion, and copper in electrical wiring because of its good electrical conductivity and ductility. So there are uh, some uses of aluminium and copper. So copper is used in the electrical wiring. First, it is good conductor of electricity, and this is ductile as well. In the food container, why aluminium is used, resistant to corrosion. Manufacture of overhead electrical cables, low density and good electrical conductivity. Manufacture of aircraft, low density. So just read the uses of metal 9.2 in your 0620 syllabus. You will find the uses. Now, the question number 15, which substances react to form hydrogen gas? Calcium and water. First of all, look at the reactivity series. So this is the reactivity series of metals along with two reference points, carbon and hydrogen. They are the reference points. They are not metals. Carbon and hydrogen both are the non-metals, but these are the reference points. So uh, which substance react to form hydrogen gas? So all the elements which are present above hydrogen in the reactivity series, they can react with the dilute acid to form hydrogen gas. So calcium and water, yes, calcium and water also contain hydrogen. So calcium and water, this can also produce hydrogen gas because this is calcium and this is metal. So the reactive metal of group 1 and some of the metal of group 2, they can also react with the water to form metal hydroxide and hydrogen gas. Magnesium is a metal which can react both with the cold water and steam. But the rest of the group 2 metals and group 1 metal, they can react with the cold water to form metal hydroxide and hydrogen. Silver and dilute hydrochloric acid, this is not possible. Silver and HCl, there will be no reaction because silver is below hydrogen in the reactivity series. Magnesium and steam, yes, magnesium and steam. Magnesium can react both with cold water and steam to make hydrogen gas. So it will make hydrogen gas, magnesium oxide plus hydrogen. Then this is correct. Zinc and dilute hydrochloric acid. Yes, zinc is above hydrogen in the reactivity series. So this is zinc. If it reacts with the dilute hydrochloric acid, we'll get zinc chloride plus hydrogen gas. So it means that 1 is correct, 3 is correct, and 4 is correct. So 1, 3, and 4. So all the elements which are above hydrogen in the reactivity series, they can react with the dilute acid to make hydrogen gas because they are more reactive than hydrogen, so they can displace hydrogen from the aqueous solution of acid. Which substances are required for the iron to rust? This is a fixed answer, no answer except these 2 points. for the resting, there are two conditions: water and oxygen. So water and oxygen, they must be there to for iron to rest. And iron rust is hydrated iron 3 oxide. So Fe2O3 dot XH2O. This is a hydrated iron 3 oxide. So hydrated iron 3 oxide, which is brown in color, that is iron rust. So these are the two conditions which are required for the objects of iron which are exposed to the moist air. They are coated with the brown mass, and that brown mass is hydrated iron 3 oxide, which is iron rust. Now, 17th, coke, carbon, and the limestone are the two raw materials used in the extraction of iron from the hematite. Which type of reaction occurs when each substance is heated during this process? First of all, the raw materials which are used to extract iron, that is iron uh, trioxide or the hematite, then the coke, then the limestone or the calcium carbonate, and then the hot air. So these are the four raw materials which are used to extract iron in the iron industry. Uh, which type of reaction occurs when each substance is heated during the process? So coke, uh, it reacts with the oxygen to form carbon dioxide. So carbon 0 to plus 4 and oxygen 0 to minus 2. So carbon is oxidized, oxygen is reduced, so redox. Limestone, thermal decomposition. Limestone decomposes to make calcium oxide and carbon dioxide upon heating. So this is the thermal decomposition. So Fe2O3 that reacts with the carbon monoxide or carbon to make iron and carbon dioxide. So this carbon monoxide is formed by reacting carbon dioxide with the more coke. We'll get the carbon monoxide, and this carbon monoxide is used here. This is also a redox reaction. So let's look at some explanation that the combustion of carbon is a redox reaction. Reduction of hematite is also a redox reaction. Thermal decomposition of the limestone, that is non-redox. Slag formation, acid base reaction, that is also non-redox. So this calcium oxide that combines with the silicon dioxide to make calcium silicate. So calcium silicate is the slag. So the impurities of sand that can be removed from the uh, iron by reacting calcium oxide with the silicon dioxide. Calcium oxide is a basic, silicon dioxide is acidic. So this is an acid-base reaction. So uh, if you want to look at the complete topic, you can uh, check this topic on my YouTube channel as well. Then number 18, the formula of the four compounds W, X, Y, and Z are given. This is W, X, Y, and Z. Which compounds are mixed to create a fertilizer containing the three elements necessary? This is also a direct question. So mostly the fertilizer, if we look at the fertilizer, so NPK, nitrogen, phosphorus, potassium. These are the three elements which are necessary for the plant growth. So NPK. So you have to look at the fertilizers which can give us NPK mixed to create a fertilizer. So W, NPK, no NPK is there. So N P. Okay, so it provides N and P, nitrogen and phosphorus, and then KNO3, it provides potassium. So it means that X and Y, if we mix X and Y, we will get the NPK, mean nitrogen, phosphorus, and potassium. Mostly, I have selected those questions in which there is a direct approach. I mean, no need to do the working, especially if we look at your specification or the syllabus, you will find that for the fertilizer, the three elements necessary to improve the plant growth, they are NPK. So you have to select those compounds which can give us nitrogen, phosphorus, and potassium. The group 1 element, the potassium forms an ionic bond with the group 7 elements, fluorine, which two ions are produced. Group 1, the student know that the group 1 elements, they can produce the +1 charge, and group 7 element, they can give us the -1 charge. So all the elements in group 1, like lithium, sodium, potassium, rubidium, they can give us one positive. And the elements in group 7, fluorine, chlorine, bromine, iodine, they will form fluoride, chloride, bromide, iodide in -1 charge. So K is +1, F is -1. Which row shows the formula of the sodium carbonate, zinc nitrate, and ammonium sulfate? For this question especially, the student must practice the formula making, and they should be able to do the radicals. Like if we have the sodium is 1 plus, carbonate is CO3 2 negative. So if we exchange the numbers without sign, we will get the sodium carbonate. Then zinc nitrate, zinc is 2 positive, and nitrate is NO3 1 negative. So you have to make the nitrate 2 times. So zinc nitrate set and NO3 2 times. Then ammonium sulfate, ammonium is NH4 positive. Sulfate is SO4 2 negative. So make the ammonium 2 times. So NH4 2 times SO4. So just practice the formula making. You can solve the question related to formula making. Which equation shows the reduction of copper? Reduction. What is reduction? Reduction is gain in hydrogen or loss of oxygen or gain of electron. So if we look at the copper, here the copper is copper 2 oxide. Here on the product side, this is copper. So when we convert the copper 2 oxide to copper, this is loss of oxygen. So loss of oxygen is reduction. And copper 2 oxide is reduced to copper, and the carbon is oxidized to carbon monoxide. So this is oxidation. This is a reduction. So basically, this is a redox reaction. Which compound is likely to be colored? So colored, this is the property of transition elements. So transition elements normally form colored compounds. The other properties are they have the high melting in the boiling points. Uh, they have the variable oxidation states. Elements in the or the compounds of the transition elements. They can be used as a catalyst. They can form the complex compounds. So colored mean KMNO4, KNO3, K2CO3, K2SO4. Now, if we look at the presence of transition element, the A option contains just one transition element, which is manganese. So KMNO4, potassium permanganate, or potassium manganate 7. That will give us the colored compound, and the color of KMNO4 is pink or purple. Pink or purple solution if we make the aqueous solution. So the aqueous solution of KMNO4 is pink or purple. The rest of the compounds are colorless. Their aqueous solutions are colorless. When a piece of aluminium foil is added to the dilute hydrochloric acid, no effervescence is seen. Which statement explains why no effervescence is seen? Aluminium is, although above in the reactivity series, but generally it show the unreactivity. So the unreactivity of aluminium is due to the surface layer of aluminium oxide. That aluminium, when it combines with the air, it is coated with the oxide coating. This is aluminium. So when it combines with the air, it is coated with the oxide layer of aluminium oxide. Generally, this oxide layer of aluminium oxide will make it inactive or unreactive. So this is stable non-porous oxide coating. When we add in dilute hydrochloric acid, so first of all, this oxide layer dissolves, because if you have aluminium oxide and if it reacts with the HCl, you will not get the hydrogen gas. You will get aluminium chloride plus H2O. So H2O will not give us the effervescence. When this aluminium oxide dissolves, and now there is a aluminium. So when aluminium reacts, you will get aluminium chloride and hydrogen gas. So this hydrogen gas will produce the effervescence. So aluminium is generally unreactive due to the stable oxide coating. So this is always the answer. Stable oxide coating of aluminium oxide makes the aluminium inactive or unreactive. The next point 24 is aluminium is extracted from the purified bauxite. So bauxite is the major substance which is used to get aluminium in the chemical industry. Bauxite is aluminium oxide through electrolysis, which row shows the ionic half equation for the reaction at each electrode. uh, Aluminium oxide, because so we take the molten aluminium oxide, so there is no extra thing which is present in the aluminium oxide. So if we ionize this, we will get Al3 positive and O2 negative ion. Al3 positive, they are the cations, so they will move towards the negative electrode, which is cathode. Anions, they start moving towards anode. Then red cat, reduction at cathode. So at cathode, there is a reduction. So reduction is the gain of electrons. So we will get aluminium. And then at anode, there is oxidation. So if we get O, the two electrons will be lost, but the diatomic oxygen is formed. So that's why we can balance this equation. So this is the reaction at cathode, and this is the reaction at anode. So aluminium is formed at cathode, and oxygen is made up of at anode. So anode is made up of carbon. So that carbon can react with the oxygen to make carbon dioxide. So that's why the electrodes or the anodes, they are periodically replaced because they react with the oxygen to make carbon dioxide. Then zinc oxide reacts with carbon to produce zinc, which equation represents this reaction. Now, zinc oxide, when zinc oxide react with the carbon, there are two possibilities, either carbon monoxide or carbon dioxide. So almost carbon monoxide and carbon dioxide are produced in every equation, and the zinc metal, it means we have to check just the balancing because the products are correct. Zinc carbon monoxide, zinc carbon dioxide, zinc carbon monoxide, zinc carbon dioxide. So these are the two possibilities. Either you will get the carbon monoxide or the carbon dioxide. The first equation, there are two zinc, two oxygen, one oxygen on the right hand side. So this is incorrect. Zinc, two zinc, two oxygen, four oxygen. So incorrect. One zinc, there is one zinc, one oxygen, one carbon, one carbon. So C is correct. As you can see, there are four oxygen, so there are two oxygen on the left hand side. So D is incorrect. Now the electronic configuration of four elements P, Q, R, and S are given. This is the electronic configuration. Which elements are unreactive monoatomic gases? So unreactive monoatomic gases, this is the property of group 8 elements. This is the property of group 8 elements, or you can say group 0 elements. And group 0 elements, they are the noble gases, and noble gases are present on extreme right of the periodic table. Extreme right of the periodic table. And generally, the noble gases, they have 2 or 8 electrons in their outermost shell or the valence shell. Only helium has 2 electrons in its outermost shell, but rest of the noble gases, they all have 8 electrons. So P2, because P2 first shell contains 2 electrons, so it means that this is the structure of helium. 2, although it has 2 electrons in the outermost shell, but this is the second shell. Second shell contains 2 electrons, meaning 4 is the proton number. So this is not the noble gas. First element is hydrogen, then helium, lithium, beryllium. This is the electronic configuration of beryllium, and beryllium is in group 2. So Q is not the answer. 2, 6. 2, 6 mean 8 electron. 8 is the oxygen. So this is oxygen. So this is not the answer. Oxygen is in group 6. This is in group 2. This is in group 6. 2, 8. 2, 8 mean 10. This is neon. So neon is in group 8. Helium is also in group 8. So P and S, they are the two elements which are present in group 8, and they are the monatomic gases, and generally they are unreactive. Which reaction pathway diagram represents the endothermic reaction? So endothermic reaction and exothermic reaction, if we want to make the energy profile diagram of the exothermic, the energy of the reactant is more than energy of the product. Here are the reactant, here are the product. This is for exo. And if we want to draw for the endo, this is the reactant, these are the product. So if the energy of the product is above reactant, so this is endothermic. So just check that the energy of the react product must be above the reactant. Now here, okay, this may be the possibility because react products are above reactant, products are above reactant, products are below reactant, products are below reactant. So you could eliminate C and D. Now, the next thing is that the enthalpy change of the exothermic reaction is negative, and the enthalpy change for the endothermic reaction is positive. As you can see that in A, the enthalpy change is negative. So this is not the answer. Enthalpy change is positive. B is the answer. This is activation energy. If we draw the uh, energy profile diagram, but this is actually a simple energy level diagram in which you will have to identify the position of reactants, products, and enthalpy change. So the reactants are below product, or products are above reactant in the endothermic change, and the enthalpy change is positive. So these are the 2 points which are required to solve this question. Then hydrogen burns in oxygen, and the equation for the reaction is given. The table shows the bond energies, what is the enthalpy or the energy given out during the reaction. So I have already mentioned the answer, but let's check how we can get this answer. So the formula for calculating is the enthalpy change is sum of energy which is required to break bonds. So you can say the sum of energies of bond broken minus sum of energies of bond formed. So bond are being broken on the left hand side. Mean you will have to consider the bonds of the reactants, and bond formed to mean the bonds of the product. So the bonds of the reactants are H bonds. So there are 2 moles. Then plus there is just 2 oxygen atoms joined through double bond. So these are the bond energy which is required to break bonds. And then water, the structure of the water is HOH, and you have the 2 coefficients there. But if you look at the HO bond, there are 2 HO bond in H2O. So if we have 2 here, so that will make the 4 HO bonds. So you can say that here you can put like there are 4 HO bonds are there. So if you put the energy 2 into 436 plus O double bond O is 498. So the energy which is required to break bond, and for bond making 464. So if you take the sum of these energies, 872 plus 498, the energy required to break bonds, and the energy which is released during bond making, that is 850. So 1370 minus 1850, this is 1370, is minus 486. So minus 486 is the answer. So this much amount of energy that is given out during this reaction. Okay, then which process involves a chemical change? Uh, Adding sodium to the water. Yes, this is a chemical change because when sodium reacts with the water, we will get sodium hydroxide plus hydrogen gas, and this is the balanced equation. Boiling water is a physical change. Dissolving sodium chloride in water, we'll get the solution. This is a physical change. Producing water from the aqueous sodium chloride, This is also a physical change. This is the distillation. In distillation, if you have an aqueous sodium chloride, you can get the water at its boiling point. This is distillation. So distillation is a physical process. Boiling water, this is also a physical change. Dissolving sodium chloride in water, you will get the aqueous solution of sodium chloride. This is also a physical change. Which statement about acid is correct? A weak acid partially dissociate in aqueous solution. This is correct. An acid accepts proton. Acid is a proton donor, so incorrect. Ethanoic acid acts as a strong acid. Ethanoic acid is a weak acid. This is incorrect. Hydrochloric acid is a strong acid that ionizes in water to form H negative ion. It will produce H positive ion. So this is also incorrect. So A is the correct answer. So this is the first session in which I have solved almost 30 MCQs, uh, and I'm going to upload this and just wait for the next videos. And don't forget to watch